Well, we did some systems of equations. Normally, you get a point of intersection because normally, your two lines, they actually meet at a single point. Today, we're going to talk about the two weird cases. Dependent systems are when you have a line and, let me do it with a highlighter, the same line. So two different versions of what turns out to be the same line. An inconsistent set of equations is when you have parallel lines. And neither of them has a nice kind of answer. If they're parallel, there isn't any intersection. If they're dependent, if they are two copies of the same line, there's an entire line's worth of solutions. So let's just talk about those two types of things separately. Inconsistent system of equations. Let's just see this. Let's just see that these two are parallel by figuring out mx plus b form for both of them. For the first one, we have 2y is negative 3x plus 8. Divide everything by 2. 8 halves is 4. Okay. This one, negative 4y, is positive 6x plus 12 when we move the 6x over. So y is 6 over negative 4x plus 12 over negative 4. Well, what is that? 6 over negative 4 is the same as negative 3 halves. 12 divided by negative 4 is negative 3. So, okay. So what we have is same slope and different intercepts. This one intercepts the y-axis up at 4. This one intercepts the y-axis down at negative 3. So we have a slope of negative 3 halves passing up through 4 and a slope of negative 3 halves passing down at negative 3. Now let's see what happens if we naively go and try to solve this equation. How do you solve this? Well, we need to get rid of a variable. Let's multiply the top equation by 2 so that we can get rid of the x's. So 6x plus 4y is 16, and write the other equation down again. And then add. Oh, so when it's inconsistent, you get a false statement about numbers, and there is no solution. There's no place where the two parallel lines actually intersect. Okay. Dependent system of equations is the two versions of the same line. The second version, I said, create it yourself, multiply by 2. So I'm just taking 2 times 3x plus 2y equals 5. So my second equation is going to be 6x plus 4y equals 10. And then my first equation was 3x plus 2y equals 5. If I go ahead and multiply this equation by 2, and subtract, I don't get a false statement, I get a true statement about numbers. Both variables died off. You can't solve for anything. You just get a true statement about numbers. And that means the answer is the line. There's only one line. We have two different versions of it. So what I can say is two versions of the way to write the answer. 3x plus 2y equals 5 is the standard form.
It's completely correct.
Or if I solve for y, let's see, let me solve for y over here. 2y is negative 3x plus 5. Y is negative 3 halves x plus 5 halves. So if I insist on using mx plus b form, which you don't have to, y equals negative 3 halves x plus 5 halves is another way to describe the same solution. Okay, slightly more complicated thing about midpoints. If I'm given a endpoint and a midpoint, I have to think a little bit harder. I can't just average. So if 5 is the midpoint between 11, I'll put 11 to the right because it is to the right, and b, well, b must be exactly the same distance away on the other side. How do you figure it out? I think the easy way this time is to figure out some distances. 5 to 11, that's 6. So I need to go 6 in the other direction. So my b is going to have to be way over at negative 1. Remember, if you take 5 and go away 6 to the left, you're going past 0. We'll do the same thing in 2 separate coordinates with a point in 2 dimensions. So the x-coordinate, we're going to do, let's see, number line, m, draw m in the middle. A is negative 4, so A goes up to the left this time. How far is that distance? Oh, it's 2. So B must be 2 more to the right. B is 0. So we have 0 comma something. And for the y-coordinate, let's see. In the y direction, 0 is m is in the middle. Always put m in the middle. If we've got 7 for A, this must be 7 to the left. So B is negative 7. Okay. Oh, that's the y-coordinate. Wait a minute. Sorry. Put it in the y-coordinate. I had it in the x-coordinate. You never saw it. So near 0, negative 7 is going to be my final answer.